Okay, dear students, today we will be going to start with Physics Paper 1, October November 2024, Variant 11. So let's start with the questions. In the question number 1, it says a crane lifts a heavy load at a steady rate. Which unit is suitable for the output power of the crane? So you might have studied about power. The power's unit is watts, symbol is W. It can be kilowatts, megawatts, whatever it is, right? So the kilo one and the mega ones are the prefixes. Watt is actual unit. So here the kilowatt is going to be your unit for the output power. In the question number 2, it says which statement about the mass is correct? Mass is a scalar quantity. Yes, it's a scalar quantity. And its units is a kilogram. Yes. So question number 2A is correct. Mass is a scalar quantity, does not have a direction, and Newton is the unit for the weight, not for the mass. So that's why your A option is correct one. Question number 3 says a bob of a simple pendulum is pulled horizontally by a force which is equal to the weight of the bob. Which diagram shows the angle between the pendulum thread and the vertical? Right. Since these two forces are equal, so it means their resultant will also be like, if I'm going to do it with the head to tail rule, this is my W, this is my second vector, and they both are same. The resultant will be from the first vector's head to the second vector's tail. To balance that, it has been attached with a string. So the string must be making the angle of 45, because when you have a isosceles triangle, this one is 90, these both are 45. So that should be 45. So C is your answer. In question number 4, it says the student takes 20 minutes to walk from X to Y at a speed of 3 kilometers per hour. She turns 90° at Y, walks with a speed of 4 kilometers per hour for 15 minutes to reach Z. What is her average speed from X to Z? Okay, average speed is taken as total distance divided by total time. Let's see what is the total distance. What is the total distance that we get? Now this is 20 minutes. Uh, speed is in kilometer per hour, so it should be converted into hours. This 15 minutes should also be converted into hours. So let's convert 20 minutes into hours. So we'll divide by 60. So that will be 1 by 3 hours. Now we will use V is equals to D over T. Our speed is given 3. Distance we need to find out. Time is 1 by 3. This 1 by 3 is going to multiply with this 3 and you'll get 1. So it is 1 kilometer from X to Y. Now the second distance is, the speed is 4. Distance we need to find out, and the time is 15. So let's convert 15 into hours. So divide by 60. So we'll get 1 by 4. So it is 1 by 4. So it is going to be 4 times 1 by 4. That is again 1 kilometer. So you'll get total distance 2 kilometers. Now total distance is 2 kilometers and total time is 35 minutes. So the distance is 2 kilometers divided by 35 minutes. So we have to convert that into hours as well. So we'll divide by 60 here. Once we're going to do this, you can do it with your calculator. I'm going to do it manually. So this is 120 divided by 35. So you'll get 3 point maybe 4. I think so. Let's do it with a calculator. 120 divided by 35. Yeah, that's 3.4. So 3.4 is our answer. Let's move on to question number 5. Question number 5 says the car is at the rest by the red traffic. When the light changes to green, the car starts moving. The graph represents the motion of the car. The car has a constant acceleration. So if it is a constant acceleration, then this should not be velocity, because in velocity the constant acceleration is been shown with a straight line. So then this quantity has to be the distance, because in distance time graph constant velocity is shown like in a straight line, and acceleration is shown in a curve like this. So at x-axis it should be distance, and y-axis it should be time. So that should be a, sorry, it should not be at x-axis, it should be time, and at y-axis should be distance. So that should be C. Let's move on to question number 6. The object falls without air resistance. The position is at equal intervals is shown by the sequence of dots. Which sequence of the dots is correct? It should be slow at the start and should be faster later on. So A cannot be the answer, because the distance is quite a lot in the start and it starts to decrease. It's not that way, because air resistance is neglected, so there is no vertical force, which means that it's not slowing down. Not this one, because it shows abnormal behavior. It shows increase and decrease, increase and decrease. C is also, it's a constant spacing between them, so it means it's not accelerating. While if you drop anything in the air, it will always accelerate with the acceleration of free fall, that is 9.81. So that's D. Some gas trapped in a container is compressed at a constant temperature by the piston. Which property of the gas does not change? Okay, since gas is compressed, so the pressure will change, the frequency of the particle will also change, and the density will also change. The mass will not change, because if you compress it, the volume changes. When the volume changes, the pressure changes, because they are inversely proportional to each other. And when volume changes, the particles are closer to each other, the collision also changes. So the frequency of the particle collision also changes. And when the volume changes, the density and volume are inversely proportional, so their density also changes. Now let's move on to question number 8. A car has a weight of 8,000 Newton. What is the mass of the car? That's easy. You know, W is equals to mg weight is 8,000, mass we need to find out, g is 9.81. So when you're going to divide it by 9.81, let's see it here, as 8,000 divided by 9.81. So that is 815. So we'll take 820 because we can round it to 820. Now let's move on to question number 9. A lorry is traveling along a straight horizontal road. The constant driving force on the lorry is 80 kilonewtons. Total resistive force is 20 kilonewtons. Describe the motion. Since resistive force is less and driving force is greater, so there should be acceleration, and the resultant force should be 80 minus 20, that should be 60. As a cyclist uses the brake on the bicycle, the energy is transferred from kinetic store to the thermal store. What causes the transfer of energy? When you're braking down, you're actually using friction, which causes this change. Because when the brakes are applied, the brake rubbers are pressed, so that transfers the energy. In question number 11, it says what is the point of Spring's limit of proportionality? It is always the point where the straight line ends. So that's V. A satellite orbits the Earth. What is the direction of the force on the satellite causing this circular motion? It is always in the direction towards the center of the Earth. So that's D. A uniform beam is pivoted at its center and balanced by the three weights as shown. What is the distance x? So you see this is pivot here. So the distance of this force from the pivot is 30, and this force is actually trying to move it this way. So that's clockwise movement. On this side, it's anti-clockwise movement. So the two forces are actually applying anti-clockwise movements. This 3 Newton and 2 Newton. But this 3 Newton has a distance from the pivot 5, while this 2 Newton has a distance from the pivot x plus 5. You can see this force, if I'm going to take the distance of this force, this is x plus 5. So now I got all the moments. So first I'm going to calculate the clockwise moment, which is equals to 2 times 30. We don't need to convert this into meters since it's an MCQs. So we don't need to convert that. 2 times 30, that is going to give you 60. This is clockwise moment. Now anti-clockwise moments are two of them. One is this 3 Newton force with the 5. So 3 5s are 15. Plus this 2 Newton with the distance of x plus 5. So that is 15 plus 2x plus 10. So that is 25 plus 2x. I am going to equate these two together because sum of clockwise moment is equal to sum of anti-clockwise moments in an equilibrium. So 60 is equals to 25 plus 2x. So 25 is going to go and subtract from there. So it will be 35 and 2 will go and divide, so that's 17.5. So that's your answer. Next it says which crosses the center of gravity of the card. A piece of card of a uniform thickness and the density suspended freely from the horizontal plane. The diagram shows the card at rest. Which cross is the center of gravity? Since you see at the base it is little more expanded base rather than the top, which is more concentrated one. So when the base is greater, so it should be, the center of gravity should be lower than the half of it. This is the middle, so it should be lower than that. So that should be C. because greater the base area, it lowers the center of gravity. Question 15 says the trolley X and mass 2 kg is moving to the right uh, of 2 at 2 meter per second. Trolley Y has a mass 1 moving to the left of 1 meter per second. They collide and stick together. The collision takes total time of 2 seconds. What is the average force acting on the trolley X during the collision? So what we need to do is, first of all, we need to know that after collision, at what speed is trolley X traveling. Then we're going to find the average speed. So first of all, we're going to apply m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. This is the initial momentum of X, which has a mass 2 and speed 2 as well, velocity 2 as well. Okay, Y is traveling with a mass of 1, but it is traveling opposite, so I should make minus 1 because these are velocities. If I'm going to take this positive, I need to take this type, the trolley as a negative, is equals to the final momentum. So mass of X is 2, but we do not know the velocity, so we're going to take as V, and mass of Y is 1, and we do not know velocity, so velocity will take V. These V will be same because they actually stick together, so they're traveling with the same speed. So 2 times 4, 4 minus 1, 3, and when you add them together, this is 3V. V is equals to 1 meter per second. So now they are together moving at the speed of 1 meter per second. It means this X has reduced its speeds from 2 to 1. So the change in momentum will be equals to mv minus mu, and I'm going to divide by t, so I'll get force. Mass final speed was 1, initial speed was 2, time it has already told us that is 0.2. So once we want to solve this, this is 2 minus 2, this is minus 2 over 0.2, so this is minus 10. Since negative only shows the direction, so it's 10 Newton. Question 16 says an object of a mass m kg is moving at a constant speed. It has a kinetic energy of 10 joules. What is the speed? Very easy. You will apply the formula of kinetic energy, which is 1 by 2 mv square. Kinetic energy is 10 joules. Mass is given 5. We need to find out v. 2 will come up here. So that's 20 divided by 5 is equals to v square. So that is 4v square, square root on both sides. So v is equals to 2. A wind-up radio is used in areas where main electricity is not available. A person winds a spring in a radio using a handle. When the spring unwinds, it makes a small coil rotate in the magnetic field. Which energy is not used in the radio? Elastic potential is converting into electrical. Yes, it is converting electrical energy into thermal, kinetic energy into thermal, chemical energy to elastic potential energy. Yes, it's also converting kinetic energy to sound. So most probably this thing is not a useful for this radio. This is not useful. Rest is all useful. Right? So B is your answer. Because thermal energy is used as a wastage. It does not get any use. The energy is transferred in a filament lamp at a rate of this. The lamp wastes energy at a rate of this. What ratio is used to calculate the efficiency? Very easy. This is useful over total input. Useful is, since it's waste 46, so the only useful is 14 over total is 60. A liquid is held in a cylinder container. The diameter of the base is d and the mass of the liquid is m and the depth is h. Which expression gives the pressure due to the liquid on the bottom of the cylinder? So that is equals to mgh. This is actually the pressure due to the liquid on the bottom of phase. But since we do not have any this type of thing here, so we have another pressure formula which is force over area. Force, since it's a weight, so we're going to use mg, and the diameter is d, so since we use radius for the circle for the area, so that is pi r square. So now I'm going to replace r with the diameter, so that is d by 2 square. So when I'm going to expand this, this will become d by 4 and 4 will go and multiply up. So that will be the expression 4 mg pi d square. Okay, so now it says the density of this. What is the atmospheric pressure? Atmospheric pressure, you should be learning, like you should know that atmospheric pressure is 1.01 into 10 to the power of 5 pascals. But since he's asking us to calculate from here, so we are going to use this height. Always use the height which is from the surface of the liquid till the point of rise. So we're going to use 760 and density is given, so we're going to use pressure is equals to rho gh. Sorry, in the previous question I used mgh, it was rho gh. Okay, so to calculate this, we have a density 1.4 into 10 to the power of 4. We have a g which is we're going to take 9.81, and then it is 760 into 10 to the power of minus 3. Since it is in millimeters, so I'm converting into meters. So now if I'm going to multiply them all together, what will I get? Let's see. This is 9.81 times 1. Pardon me for today, I don't have a calculator right now. 9.81 times 760 times 1.4. Oh, my internet is not connected. Let me connect it, please. Okay, so I'll use a calculator from here rather. So that is 9.81 times 760 times 1.4. This is going to give me this, and I need to times it with 10 to the power of 1 as well, because they both will give you 10 to the power of 1. So I'm going to use multiply by 10 as well. So it is going to give me 104. So it is going to give me 1.04 into 10 to the power of 5 pascals. So 104 kilopascals. That's correct answer. Air at atmospheric pressure and the room temperature is trapped in an insulated container by a frictionless piston of negligible weight. The air can be compressed by placing a masses on the top of the final piston, top of the piston. Right. The mass of 1 kg is placed on the piston and the volume of the trapped air decreases from this to this. Okay. Which statement is correct? Adding another 1 kg mass decreases the volume of the air by less than 10 centimeters cube. We'll see that I'm not doing it either right or correct. Addition of an additional 9 kg mass will reduce the volume of air to 0. No, it's not. So that's incorrect. The pressure of the trapped air is less than atmospheric pressure when its volume is 90. No, it is more than atmospheric pressure. The temperature of the air decreases by 1 kg. No, that's wrong. So the only thing is adding another 1 kg will decrease the volume of air by less than 10. So this will not continue. This ratio will not continue. Once you add more mass, the pressure inside will start to increase. So it will not decrease by the same volume. The volume will decrease less. Moving on to question number 22. The substance has a melting point of minus 17 and the boiling point of 117. Which state does the substance exist at minus 10 and at 110? At minus 10 it will be liquid because it is going to be melted at minus 17, so it will be liquid. And at 1110 it is going to be liquid again because the boiling point is 117. The thermal energy supplied at a constant rate to a fixed mass of a substance that is initially solid. The graph shows how the temperature of the fixed mass of a substance varies with the time. Right. In which section the graph does the substance absorbs the latent heat? So latent heat is these two when the state is changing. So that X and Z. A piece of paper is torn out of the exercise book is shown as a average kinetic energy of the molecule decreases, the space between them decreases and they move downwards. Which process is being described? Uh, it's convection, because the convection is to do with the uh, molecule's density. This becomes less dense. The average kinetic energy of the molecule decreases means temperature is decreasing, because temperature is actually average kinetic energy. So when the temperature decreases, so they become denser, so they will move downwards. So that's convection. A ray of light passes from a glass to the air. Which arrow shows the ray of, so normally it should go straight, but since the medium is different, so it should bend away from normal This is our normal. So it should bend away from normal because it is going from denser to rare. A short sighted student looks at a distant object. Which row shows the position of the image in the short sighted eye and the type of lens used to correct short sightedness? Uh, the position of the image in the short sighted eye. So let's see short sighted eye. I'm going to show you a short sighted eye so that you can have a good view of that. My internet is not connected. Let's see if it gets connected now. I think so. It does not show the internet. There's a problem with the internet today. So there's no internet. So just give me a second. Let me connect my other internet. Oh, sorry. There's no internet connectivity, so I'll have to explain it here. If this is like your retina, the ray of the lights they converge before retina. This is short-sighted eye, and it should have to be converging on a retina to give you a correct display. So, first of all, it is in front of retina, and to correct it, you need a diverging lens. The diverging lens is going to diverge a little more, and then when it is entering into the eye, it will converge on the retina. A student makes four statements about infrared. They can be seen by the human eye. No, they cannot. They travel at 330 meter per second in the air. No, they do not. They travel with the speed of light, which is 3 into 10 to the power of 8 meter per second. They are transverse waves. Yes, they are transverse waves. They are used in intruder alarms. Yes, they are used in intruder alarms. So that's 3 and 4. Which waves are longitudinal sound waves always? The rest are all electromagnetic waves which are transverse. A person hears an echo after a sound hits the solid cliff face. What causes the echo? That's a reflection of the sound. The plastic strip is rubbed with a cloth and the plastic becomes negatively charged. Which statement explains? If plastic becomes negatively charged, it means it's gaining the electron. So the electron transferred from earth to the plastic, electron transfer from the cloth to the plastic. Yes, cloth loses electron. That's why that's why cloth becomes positively charged, and plastic it gains electron. That's why it becomes negatively charged. Two parallel connecting plates are charged. The charge on the upper plate is positive. Okay. The charge on the lower plate is equal in size but negative. Okay. The diagram should okay. So it should always be field is always from positive to negative. Direction should also be positive to negative. So that's C. Which quantity is defined as electrical work done by the source in moving the unit charge around a complete circuit? That is E. Definition of EMF. Four 1.5 cells are connected in the circuits. Switch is closed. What is the reading on the voltmeter? So since there are four of them, so 1.5 plus 1.5 plus 1.5 plus 1.5. So these are six switches. What is the reading on the voltmeter? The voltmeter is going to read 0 here. Reason is the voltmeter should never be connected in the series. It should always be parallel. Like this. It's been connected here. Okay, so two resistors are given. Series with a battery. The reading on the three voltmeters V0, V1, V2 and the current 0, I0, I1, I2 are shown. Which rows gives the value current I0 and the potential difference V2? I0 is equals to I1. It should also be I equal to I2 because in series the current remains same. So C and D is incorrect because it's not sum of I2 and I3. And V0 is equals to V2. No, V0 is equals to sum of these two. So that's B. The current in the home computer varies between 0.4 ampere and 1.2 ampere when the computer is connected to the main supply. What is the rating of the most suitable fuse to use to protect the computer? So it should be little more than 1.2. Since it varies between 0.4 to 1.2, so I would be using 1.2 ampere because 1.5 will be a little higher. Rather we should use 1.5 because in the normal operation when it goes to 1.2 it will switch off. So 1.5 is a better answer. A student are asked to draw the pattern and the direction of magnetic field due to which the current is. The diagram shows the student do not know the direction of the current. That's very easy. You use right hand grip rule. So your thumb has to point out toward the direction of current, and the curl of the fingers will point out the direction of the field. Since if I'm drawing it with my thumb, the curl of the finger shows that the current is going up here, it is going up here, and it is going down here. The student do not know the direction of the current in the wire. Which diagram shows the possible pattern and direction of the magnetic field due to the current in the wire? Which diagram shows the possible? This is not possible because one ring is going this way, the other ring is going this way, so that's wrong. So it's 1 and 3 which is actually showing the possible ones. Which rows identifies the positive and the negative particle in an atom? The positive is proton, the negative is electron. The nuclide notation of a certain isotope Q is this. What is the total number of neutron, proton and electrons in this? Total number of, so proton, these are electrons, these are protons, and neutrons are this. So Z gets cancelled, so it's Z plus R. Which list shows the planet in order of increasing distance from the sun? Mercury is at the start, then it's Venus, then it's Earth, then it is Mars, then Jupiter, Saturn, Uranus and Neptune. A student spills the ink on the page of the textbook and defines redshift. The ink covers the three important words 1, 2, 3. The redshift in dash dash in an observed dash of electromagnetic radiation emitted from the dash stars and galaxies. Okay, a redshift is an increase in the observed wavelength of electromagnetic radiation emitted from receding, because the stars and galaxies are always moving away. So that's it. So that's it. So we've done, like, we've gone through all the key concepts. I hope you liked it. Since it was a live recording, so I might have made any mistake here, so pardon me for that. And in the next class we'll go through the next set of papers, and get connected with this channel, uh, like and subscribe so that you can get each and every paper here. Thank you very much. Allah Hafiz.